Indirect measurement, casting shadows. You guys have asked me for other examples of when you would use similar figures, and this video will show you some real-world examples or applications of similar figures. Let's read this problem. I want you to write it and draw it in your notebook. A really tall building casts a 50-foot shadow. So here is the really tall building, and it casts a 50-foot shadow. Actually, I'll put the really tall building right here. It casts a 50-foot shadow, and at the same time, a 50-foot building, so here is the 50-foot building, casts a shadow that is 12.5 or 12 5/10 feet long, or, casts a 12-foot shadow. Use proportionality to determine the height of the really tall building. So we have to figure out this height. Well, what do you notice about the shapes that we have here? If you connect these, they are actually triangles. And these triangles are similar, so we can use proportions to determine the height of the building. So we know that these two shapes are similar, so what are we going to do? We are going to draw a ratio table. So here's my ratio table, and I'm going to put the tall building on this side and the short building over here. And I know that this shadow for the tall building is 50 feet, and the short building's shadow is 12.5 feet. Those are corresponding. The tall building's height is what we're looking for, so we're going to call that H. Actually, I'm going to move that H down here. And then that corresponds with 50 feet high on the short building. So now all we have to do is scale this. So you guys know that there are lots of relationships that we can look at, and we can say 12.5 times 2. We could double it to get 25. So over here we would need to double it because we have a proportion. So that would be 100. And then can we get 25 up to 50? Yes, we can double that again, multiply it by 2. So what is height actually equal to? 200 feet. We could have scaled directly by 4, or we could have gone horizontally as well. So make sure that you have written this down. You pause and you rewind if you did not understand how to scale that. But we have determined that the height of the building is 200 feet. So that's an example. We couldn't actually measure the height of this building because 200 feet is really, really tall. Can't get out there with a meter stick. So that's one way to use similar figures through indirect measurement. A 6-foot tall person, make sure you write this down in your notebook. A 6-foot tall person is standing next to a flagpole. The person is casting a shadow 1.5 feet in length, while the flagpole is casting a shadow 5 feet in length. How tall is the flagpole? Let's draw a picture. We don't have one, so we know a 6-foot tall person. So here's our person, and that person is 6 feet tall, and it's standing next to a flagpole. So here's our flagpole. The person is casting a shadow that's 1.5 feet in length. So here is that person's shadow right here. We know that it is 1.5 feet in length, while the flagpole is casting a shadow 5 feet in length. Feet in length. We need to find the height of the flagpole. So we know this person's height is 6 feet. The shadow is 1.5 feet. We know the flagpole's shadow is 5 feet. We need to find, we can call it H, X, whatever we want, X, the height of the flagpole. And if we, again, connect those, we have two similar triangles. So let's set up a ratio table and use proportionality to determine the height of the flagpole. go ahead and pause the video. Do that right now and see if you get the same answer as me. Alright, so ratio table. So we've got person and flagpole. And the height of the person is 6 feet, and that corresponds to X feet for the height of the flagpole. And then the person's shadow is 1.5 feet, and that corresponds to 5 foot shadow for the flagpole. So we actually, I have it written to where we need to scale 5 to something, and we need to scale 1.5 up to 6. So if I multiply, let's just start doubling, because sometimes that is helpful if you can't see a direct relationship. So 1.5, if we double it, oh, that's 3. And then we can do the same thing. We can double 3 to get 6. So 5 times 2 is 10. And then times 2 again is 20 feet. So the height of the flagpole is 20 feet. Now, both of these examples required me to multiply by 2 and then multiply by 2 again. That is not always the case. There are other ways. There will be other situations where you're not just multiplying by 2. So make sure you have that written down in your notebook. And congratulations, you're welcome. There is no risk, but make sure you have copied the problems and solutions in your notebook.